Now let's take an example of a voltage divider in this example right here. So R1 is going to be 4.56 ohms, R2 is going to be 20 ohms, and R3 is going to be 330 ohms in both circuits. Now, what we're going to do is we're going to first of all find out the voltage drop. This is going to be the voltage drop across R1, V1, and then we're going to find out the voltage drop across R2 and R3. Now, you can call that either V2 or you can call it V3. Doesn't matter because it's the same value, but we're going to distinguish between the two. All right, now we also know from Kirchhoff's voltage law that the voltage supply in this case, which is the electromotive force, let's not forget about that, is going to be equal to V1 plus either V2 or V3. Doesn't matter. I'm just picking V2 here. So how are we going to tackle this? First of all, we need to know the voltage that is applied across both resistors here. And both resistors, I mean V1 and V2, V3. However, we see that there are three resistors. That doesn't work for us. What we need is R1 as such, and then we need another resistor because we said that the voltage divider is going to be applied on only two resistors. So this second one is going to be R2 and 3, the equivalent of 2 and 3. So this is going to be V1, this is going to be V2 or V3, doesn't matter. But the total voltage here is going to be Vs, right? Now, Vs in this example is 50 volts. So what is the first thing we need to do? The first thing we need to do is to find the equivalent of both R2 and R3. You might remember that there are two ways to calculate this. We're going to either say in this calculation that the equivalent of R2 and 3 equal to R2 multiplied by R3 divided by R2 plus R3, which is going to end up being 18.9 ohms. You can also use the second one, which is 1 over R2 3 is equal to 1 over R2 plus 1 over R3. Either way, you are going to get this result. Which means that what we're doing is we are putting another resistor here that is the equivalent of R2 and R3 in a value of 18.9. So R2 and 3, the equivalent. And we're going to say now this is going to be V2. Okay? All right. And according to our calculations and the formulas, if you remember, V1 equals to the ratio, division ratio, which is R1 over R1 plus R2 and 3, multiplied by voltage, the supply voltage. So V1 is going to be R1, that is 4.56 ohms divided by 4.56 ohms plus 18.9 ohms multiplied by the voltage supply, which is 50 volts. And as a result, now V1 will be 0.19 roughly 43. I'm just keeping 4 digits here, 4 places, multiplied by 50, and V1 is going to be 99.7 volts. So this is an example of how we can calculate the voltage drop on V1. And obviously, we know that V2 equals to 50 minus V1, according to Kirchhoff's law, which is 50 minus 9.7, and that is going to be equal to 40.3 volts. That's your V2. So we have now V1 and V2 calculated. What is the next step? The next step is to calculate the total current, but that is going to be outside of the voltage divider example. So let's do the same thing here. Can we do a voltage divider calculation on both? So we have an R2, R1 and R2, and R3 and R4. The first thing we should notice is the nodes here. So if I take the nodes as such, this is node number 1, which is huge node right there, and I'm gonna take node number 2 like that. All right, so R1 and R2 are in series, and R3 and 4 are also in series. If I apply that rule, what I'm going to get is a circuit like this. This is going to be the equivalent R1 and 2, and this is going to be the equivalent of, so 1 and 2, which is in series. So I can actually, instead of writing that, I can do this, and this is R3 and 4, right? As you can see that the voltage supply, whatever voltage supply that is, it is going to be the same as the voltage here. So the voltage supply in this case is 50 volts. So the 50 volts is going to be applied here and here. So the voltage drop, so if I go and say V1 and V2 and V3 and V4 representing the voltage drops on each resistor, we are going to know from Kirchhoff's voltage law that 50 is going to be equal to V1 plus V2 in this circuit here, and it's going to be equal to V3 plus V4 in another circuit that I'm going to represent with a red here. Now you're going to say, okay, so do we have two circuits here? Well, I should have said loops actually, but the voltage drop between the red node and the blue node is the same whether you are looking at 3 and 4 as a branch or 1 and 2 as a branch. Voltage drop is going to be the same. All right, so what we need is to apply the voltage divider either on V1 and V2 or 3 or 4. We're going to work on one at a time. All right, so let's have a look at the voltage drop in V1 and V2. Obviously, I'm going to repeat the same formula. V1 equals to R1 over R1 plus R2 multiplied by Vs. In this case, we said Vs is 50. All right, and what we're going to do is we're going to repeat the same. V2 equals to R2 divided by R1 plus R2 multiplied by Vs. Now I'm going to provide you with the values. So R2 is going to be 100 ohms, and R1 is going to be 33.33 continued ohms, and R3 is going to be 50 ohms, and R4 is going to be 50 ohms. I would like you to pause the video and try to figure out the voltage drops. Obviously, V3 is going to be R3 divided by R3 plus R4 multiplied by Vs, and V4 is going to be R4 divided by R3 plus R4 multiplied by Vs. You're going to notice again, I keep repeating this, you're going to notice that the idea is that this whole voltage here between this node and this node is going to be the same, whether you are reading the voltage drop between red and blue across R3 and 4, or you're reading the voltage drop between red and blue across R1 and R2. Please stop the video and try to figure out the V1, V2, V3, and V4. Finally, what you would want to do is you would want to do the same calculation on this circuit. I would remind you that in this circuit, R1 and R2 are not in series. Instead, 3 and 4 are in parallel. So that's something that you have to bear in mind when you are doing the calculations.